Okay, so I'm going to help you out if you need a little bit of help constructing this graph for the Charles Law graph. Here's some help. So first of all, just to back up a little bit, you have this data table, right? So you guys should be able to take your temperature and convert to Kelvin. And then for that distance, just remember, like whatever these distances are, to convert it to volume, you just use that conversion factor that you came up with right here, okay? And you can convert that distance in millimeters to volume, how much gas is in that space. And then to get the total, remember 4.80, that's the volume of the bulb, the fat part. And then you just have to add whatever volume there was in that stem, that little bit, okay? And that's your total. So what you're going to graph is actually this column and this column, okay? All right, so what that's going to look like on Google Sheets is you typed in a heading, okay, and you got temperature and volume, and then you just typed in your data. Okay, now I'm going to warn you, yours will not match mine. I promise you 100%. You're going to have different numbers here, and you're going to have different numbers here, okay? So we're just going to go ahead and select that. All right, and then I'm going to come over here and insert chart. So it looks something like this. It's got the volume on the Y and the temperature on the X. Okay, so then I'm going to go over here to customize. Okay, the first thing I'm going to do is I want a best fit line. So under series, I'm just going to scroll down a little bit here until I see that trend lines. So I'm going to click that box. Okay, so now I have a best fit line. And then while I'm at it, I'm just going to continue on because I'm going to want an equation for that best fit line. So I'm going to go ahead and say use equation. Okay, and while we're here, you might as well just click that show R squared. That basically is just a statistical thing. The closer that number is to 1, that just means that your data is fitting linear data, that your data is good. So we're at 0.993, so this data is looking pretty good. All right, now we want to know what the x-axis is. So we need to know when this line is going to cross the x-axis. So we're going to keep going down, and that says right here, horizontal axes. Okay, and if you scroll up right here, it says min and max. So we need that minimum to be a little bit lower. So I'm going to type in 0 and see what happens. Okay, and for me, I can see where the x-intercept is. It's right about there. So yours is probably going to be someplace over here. So you may have to make this like -20 or something like that, so that like if you go into the negatives, you can see where it crosses the x-intercept, this line right here. Okay, from there, you can go ahead and make your title a little more descriptive. So like volume of what? So maybe volume of trapped gas in a pipette, something like that. All right, that's looking to be a really good graph. Now, what I'm going to show you is the last thing. So you can see from my data, which is going to look different from yours, that my data is really good. So like if you play your cards right, it should cross the x-intercept at the 0 point, and I'm pretty close to that. So I think, if I estimate where that is right there, it's probably like 3 Kelvin, something like that. So it's very close to 0 Kelvin. But you guys can calculate that by using this equation of the line right here. So let me show you how to do that. So I'm going to go back in, okay, and you guys can see basically right here, this guy right here means y equals mx plus b. Okay, so this is the point I'm looking for. Okay, it's the x-intercept, right? X-intercept. So what is y at the x-intercept? So this is y, okay? And right there, it looks like y equals 0 at the x-intercept. So what I'm going to do is just basically solve for that. So 0.163x plus, and this is in scientific notation. It probably isn't for you, but it might be. So it looks like that. So I just made that a normal number. Okay, that looks good. So now all I have to do is solve for x. Okay, so for the algebra, let's see, I'm going to subtract both sides, the 0.00667. I'm going to subtract that from both sides. Okay, so that's going to leave me with 0.00667 equals 0.0163x. And then, how do I get x by itself? So the last step is I'll just divide this and put it on the other side. So it crosses out. This crossed out right here. So basically, it's being added right here. So you had to subtract. That's the opposite of adding. And this right here, it's times x. So the opposite of timesing or multiplying is divide. So it crosses out on this side and basically end up with x equals negative 0.0067 divided by 0.0163. So if I divide that out on my handy calculator, I'm just curious how good this data really is. Okay, it came out to about, wow, 0.41 Kelvin. Okay, so that is really good. Yours is going to come out different, I promise. So make sure you guys do the calculation for your best fit line. All right, well, I think that's it. If you have any questions, don't hesitate to ask. There are some analysis questions on the next page of the lab, so make sure you guys answer those as well. All right, text me through mine if you have any questions.